know that cancer is a deadly disease. In spite of remarkable progress in chemotherapy, cancer patients experience huge side effects such as anemia, hair loss, heart failure. Why is that so? Well, the drugs to treat cancer are not some magical molecules that they only kill cancer cells. They also harm useful and healthy cells and organs. So, how can we make these drugs safe? Well, one of the solutions is using a prodrug. Prodrug is a protected form of a drug that remains dormant until they get activated by a specific chemical reaction. Now, in order to achieve a safe and efficient cancer treatment, we need to control where and when these products will be activated. To do that, in my PhD research, I am using nanoparticles. Nanoparticles are very small spheres that can perform reactions in our body without causing harm. I use them to activate the products. What is great about these nanoparticles is that by a simple tweak in the structure, I can control where these nanoparticles will go and how fast these nanoparticles will activate the prodrugs. In the figure, you see a normal healthy cell on left and the cancer cell on right. The prodrugs do not cause harm to the normal cell, but in the cancer cells, they get activated to drug by the nanoparticles and eventually causing the cancer cell to die. Using this strategy, I have achieved cancer cell killing with high efficiency in a human-derived cancer cell line. Currently, I am working on mouse model to test this strategy further. Why mouse? Well, mouse shares 95% of our DNA that makes them genetically very similar to us. The compound that works in mouse has high potential to be working in human beings. So, prodrugs improve drug safety, nanoparticles control when and where those products will be activated. Mouse model help to move the strategy from laboratory to the clinics. And I hope that this will lead to a safer cancer treatment that not only will cure cancer, also will provide the cancer patients highest possible quality of life during and after treatment. Thank you.